plane and below the surface, z equals 2 minus x to the fourth minus y to the fourth. And x is from -1 to 1, and y is from -1 to 1.
And essentially, z is going to be between 0 and this guy. Okay. Yes, I should find who the divergence of f is first. So it's the partial derivative with x, add the y, add the z. Okay, if you do this with respect to x, it doesn't matter because the answer is 0. And if you do this with respect to y, you get a yucky 7 minus x squared. And if you do this with respect to z, you get a 0. So I just get a 7 minus x squared inside the square root. That lighting system is going weird. What in the heck is going on? Because I can hardly read it. Let me try that. Much better. Because there was a kind of glare there that would probably hurt your eyes if you had to stare at it for much left. Double check 0 with y, you just get this term and that. So it looks like the divergence is this fella. Is that correct? I'm not happy with that because that's a very unfriendly integral. You'd have to look that up as a standard answer, but I guess I can come to that in a minute. It's basically just going to be this region here, right? E is this fella. So it's probably that was causing you the trouble. What, the integral of this? Right, let's figure out what it is then. The surface integral that we were being asked to calculate, which is this guy, because of the divergence theorem, we can calculate this triple integral instead. And it's pretty clear to me that this is going to be an XYZ situation. So it's going to be from x equals -1 to x equals 1, from y equals -1 to y equals 1, and from z equals 0 to 2, take away x to the 4, take away y to the 4. And the guy that we're going to do is this guy. And we're going to do a z, going to do a y, and then we're going to do an x. Okay, let's do the z. So that's going to get me x is -1 to x is 1, y equals -1 to y equals 1. You stick essentially a z next to that, and you evaluate it at z equals 0 and z equals 2 minus, God, this is getting worse. So what do I have here? Well, the 0's nice, but the other bit is not. It's 2 take away x to the 4, take away y to the 4. The square root is 7 minus x squared. No. There is no way that is going to be nice. Okay, this is question number 4 from divergence. Unless I've misread the question, this integral isn't going to work. It's just not going to work. Well, I guess I could do the y to the 4s, but I know it's going to be left. I'm going to be left with x to the 4s and square roots of 7 minus x squared and some numbers. And that's not a standard integral. That's not something I could be able to tell you what the answer is without any trouble. So let's see. What the heck? Oh, come on, darn and spicing. Cengage decided to time out on me. That wasn't very nice of it. I mean, you could all probably go and have a coffee while I load this darn thing up. Weird day today. I'm not sure what is going on with this particular question. All I know for sure is that the integral that I'm looking at is not doable. So there must be something else going on that I'm not aware of. So let's do a view on this. And this is question 4. Let's put a solution on it so we can see what it thinks it is. Now let's click on that solution. Oh, you're going to like this. And I mean that in a way that you're not going to like this. This is their solution. They set up the integral the way I did, and then they miraculously tell you what the answer is. That is not even vaguely fair.
And actually, it's not the right problem, because this is a 6 minus x squared. Our problem is 7 minus x squared. So it's not even
the same one. I could fix the 6's because I could guess those. I could not fix these because I don't know where they came from. I guess the bottom line is that question should never have been asked. There is no, I'll finish off by telling you why it's impossible to do analytically, at least from my perspective. You're going to stick a y in there. That's just going to give you one of these and one of these. And the result is that you're going to get, essentially, you're going to get guys that look like this with some multiple, and maybe some guys that look like this, right, with some other multiple. So you're going to get like 7 of them and 4 of them. That one I could look up as a standard integral. Look up that guy and just write down what it tells you. This one here, there might be a standard integral for that. Now I'm thinking about it, but you'd have to look up something that would look something like this: x to the n, the square root of a squared minus x squared. And it's not that you actually integrate these. All standard integrals are is someone else has done the question for you and they put it in a big table and you go and look it up. So the bottom line is, I'm not surprised you have the trouble with that. It's a horrible question. I'll probably just delete it once this class is over and just make sure I don't ask you anything that looks like that on the final, because it's unfair. It didn't look particularly strange when I chose it. I guess I should also check all the solutions when I pick questions. Sorry, bad question. That's basically the bottom line. Do you know where to find standard integrals? I mean, things that other people have done. In most textbooks, there's an appendix at the end where it has, depends on what the book is, a couple of hundred standard integrals that you would just go and look for when you get stuck. But since I'm not going to give you a question where you would need to do that, we won't worry too much about it. I mean, it was a good start. I mean, this guy here wasn't too bad. Do you know what they could have done? Do you know what they should have done? See if they'd made this an x. No, that wouldn't have worked. See if they'd made this an xy. That would have turned into an x, and that would have turned into an x. And wouldn't that have worked as a u sub? You'd have to change this, of course. Just make it a 2. So, I mean, there is a workaround for it, but not the way it was written. Okay, what you got next? Hopefully, I can be of more use than just tell you it's a bad question.
could you do number 11 from the divergence theorem homework?
I'm getting worried about this section. I would hope that 11 is nice, so let me set it up. Let's find it. Question 11. Right. The version I've got in front of me is what? Here we go. We are vector field is xy e to the z, xy squared z cubed, and then negative y e to the z. Does that look like yours?
No, not at all. Mine looks like
Oh, I'm looking at one.
okay.
Yeah, there's not a lot of difference. Question 10.
Question 11.
Question 11. I should go back to bed. Question 11. Oh, okay. I have an x to the 4. I have a negative x cubed z squared, and I have a 4x y squared z. Does that look good?
Yeah, yeah.
Yeah, and the surface S is made up from a cylinder, which is that guy. And then it's cut with a diagonal plane, which is essentially what that guy is. And Z is going to be from here to here. Okay. Now, because of this guy, especially because of this guy, I'm going to go polar. So I'm going to go R is this fella, Y is going to be this fella. The Z is going to be R cos theta plus 9, and the Z is going to be 0. So since this is a circle radius 3, the region is going to be radius of 3. Since it's a cylinder, when it hits the ground, it's a complete circle. So that's why I can do these two guys. And then the sloping part is the Z guy. And we know it's on 0 on one side, and on the other side, converting it, we get that. So is that the way you approach that question?
Yeah, that is.
Okay, so let's continue with the problem. So what I need to do is find the divergence, which I should have found first, because it might have been 0. But there it goes. Divergence of f is, if you differentiate this guy with respect to x, you get that. If you differentiate this guy with respect to y, you don't get anything. And if you differentiate this guy, you get that. So it looks like the divergence only has x's and y's in it. But if it had any z's, wouldn't I replace the z's with r cos theta plus 9 later on? So I would have coped with it if it did have it. Might as well fix it right now. 4r cubed cos cubed thetas plus 4 r cos theta r squared sine squared theta. That's going to get me 4r cubed cos cubed plus 4r cubed cos theta sine squared. Okay, look for style points. Is there anything you can do to this expression that might make it prettier?
Factor out the 4r cubed.
Anything else?
And a cosine if you'd like.
I would like, because guess what's left? So we're happy about the div of f being that guy now. So we set up our surface integral. And convert it into a triple integral. And the triple integral is going to be for no particular reason, r equals 0 to 3, theta equals 0 to 2 pi, and z equals 0 to z equals r cos theta plus 9. The divergence, which is this guy, and r, a dz, a dr, and a d theta. Is that enough, or did you? You've done everything exactly the same as this? Is it? Do I need to go further? I guess I'm asking.
Yeah, I would like you to go further.
Okay. So, going to be r equals 0 to r equals 3. This guy's not going to do anything. Essentially, all of that's just going to have a z attached to it. So what does that get me? It gets me 4r cubed. No, it doesn't. 4r to the 4 cos theta, if you combine them. 4r to the 4 cos theta times this guy. Take away nothing. Let's see what that looks like. Well, you multiply this by this, you get 4r to the 5 cos squared theta. And then you get plus, what's that, plus 36 r to the 4 cosine theta d theta dr. Is this variable separable?
I think I just realized what I did wrong, but not yet. You have to turn the cosine squared into
A half 1 plus cosine 2 theta. Yeah. Now,
Yeah.
this question is not variable separable, but do you know if you split it into two different integrals, aren't both of those variable separable, and that might reduce your workload just a little bit? Right, you get what I'm saying there? That you could call it 0 to 3, 0 to 2 pi of this guy plus 0 to 3, 0 to 2 pi of the other guy. And I think you could split that up and split that up. It'd be different splits, but you could split them up. And that might reduce your workload a little bit. At least it'd make it less ugly, and less ugly tends to reduce mistakes. Are we good with that question now? Okay. What's our next one? It doesn't need to be a specific question. Yes?
Can we do question 10 from 6.5?
That's an interesting choice. Number 10 from section 6.5. Is that a short question, or will I have to go looking for it?
Yeah, it's finding the curl and div of f is 0, and then it's comma cosine xz, and then comma negative cosine xy.
Right, guys? So it's
Correct.
a curl and a div?
Yep.
Of f, of course. Okay. You want to get a curl? Let's do that first then. It's an I, it's a j, it's a k. Partial x, partial y, partial z, the operator. 0, cosine of xz, and then negative cosine of xy. Okay. And it's the curl then is going to be so many i's, take away so many j's, plus so many k's. Okay, if you differentiate this with respect to y, right, you differentiate a cosine, you get a negative sine, so that's going to get me positive sine xy. but you also differentiate xy with respect to y gets you an x. Now subtract. If you differentiate this fella here with respect to z, you get a negative sign. So two negatives make this a plus. And you get a sine of xz times the derivative of xz with respect to z gets you an x. So you got an x sine xy plus an x sine xz. Okay, middle one. If you differentiate this, you end up with a positive sine of xy times the derivative of xy with respect to x gets you y. Take away nothing. So that middle one is negative y, the sine of xy. And the last one, if you differentiate this, you're going to get a negative sine of xy times the derivative with respect to x, which gives you z minus 0. So I make that negative z, the sine of xy.
I think it's got to be sine of xz on the last one.
Is it xz? Oh, you're right. It's a z. But apart from that, it's, ooh, yeah, it's still the right one. So apart from that, we're good. The div. Well, the div is simply just partial derivative of this with respect to x, this with respect to y, and this with respect to z, which means 0. That's nice, a little bit surprising, but nice. Which means, not that this was this question, but if someone went and asked you to do this fella, couldn't you just say the answer was 0? How can I say that? What have I used, although I've not written it down?
The integral of 0 is 0.
Yeah, I've used the divergence theorem. And it doesn't matter what that is or what variables you use. If this is 0, isn't the integral of 0, 0, no matter what variable structure you use to describe the region.
Rather than a specific homework problem, can I ask you, we have like so many ways of dealing with surface integrals now. Like what are our cues to tell us when we should just do a surface integral the regular way as opposed to using one of the theorems? Or
typically I tell you in the question. So I will say use the divergence theorem to find the thing. If I can go and have a look at what I did in the practice final, I say maybe find one, hopefully. What I just said is true, because that's what I typically would do.
okay.
Since that's, let's do a divergence one, that's quite near the end, right? So I would probably have that as the last question. So with a bit of luck, I'll be able to find it relatively quickly. There we go. Use the divergence theorem to calculate the surface integral. Right. So in the question, it's telling you the method. Now, when you're told to use the divergence theorem or Green's theorem or Stokes' theorem, right, depending on the question, it's not a suggestion, it's an instruction. It says, do it this way. Even if you could do it other ways, which you've just mentioned you could, especially surface integrals, right? Don't. Do it only the way they're asked. Because what I'm testing here is, do you know how to do a divergence theorem? Maybe the next question I'm testing, do you know it's the Stokes theorem? Now, if I left an open-ended one, which I wouldn't want to do, no, it's called Stokes. I guess I have. If I left it open-ended, in other words, I didn't give you an instruction of what method to use, then pick whatever method you like. I would try and pick the one with the least amount of work. What would that be? Well, if I was given a random question, right, and it was find a surface integral, right, find this guy. Now, there are two different ways. Couldn't I convert it into a line integral, or couldn't I convert it into a triple integral, right? And I'm thinking, should I go divergence theorem, or should I go, you know, a different road? I would calculate the divergence. If the divergence is 0, then I'm good to go. But if the divergence is quite a nice, simple function, that would make me think go that way. If this is horrible and messy, then that wouldn't be a clue. But if you were given an open-ended question where you weren't told what to do, any method that works is valid. So if you decide to go route A and someone else went route B, you're still going to get the same final answer. One of you might take twice as long doing that, but that's part of the joys of mathematics.
So if it's if the divergence is 0, do we use line integrals then?
No, if divergence is 0, you go like this. And your question is over.
Right.
Now, if the divergence is simple, suppose you did it and the divergence was x, right? Let's just say the way it worked out. I would be very inclined to look at this as a divergence theorem, right? A triple integral question. Because if this is x and the region S is well defined, right? Something I know I could turn into a triple integral without too much trouble, then I would go this road, right? That's a kind of vague answer, but if we tell you what to do, you do it. And if I don't tell you what to do, pick your method, but I would check for the divergence first, because if it's simple, I would go the triple integral way. Another question.
So what would be like a giveaway that you should use a line integral?
A very ugly div, a very ugly divergence. If I did divergence and it ended up being x squared y plus sine of z e to the xy, something like that, I'd be less inclined to do that. If the surface S can be defined by a very simple R of t, right? Because, you know, when you do the line integral, you're going to basically try and do the boundary of the surface, right? If that is something very easy, I might go a line integral way. And I would assume, I'm just saying this off the top of my head, that there might be many questions where it's 6 of one and half a dozen of the other. In other words, both methods are fine and they're both about the same amount of work. It's quite difficult actually to get these guys where the answer is doable with a manageable amount of math. Do you know if you just randomly pick an F and randomly pick a surface, the chances are you'll end up with an integral, whether you do it the divergence or the line integral method, that is extremely difficult, if not impossible to do. And I think a candidate for that one was the one that Eleanor picked up right at the start. Would you agree that that integral was just ridiculously ugly to do by hand? Which was why it should never have been there in the first place. So the types of integrals that you're expected to do are physical ones that are relatively symmetric or nice. And those ones can work equally in both directions. But I love symmetry. If you see symmetry floating about, that just makes your life easy. And it tends to make answers nice. Tends to.
So if there's
No, keep going.
If there's something that's like a kind of a non-linear looking function, like a trig function, is that like a reason to avoid a line integral and go with Newton's theorem?
It's a good question. I don't have a good answer because I can imagine in some situations a line integral would be nice and the triple integral would be horrible. But I could imagine other situations where they would switch places. So I don't think there is a hard and fast rule that way. I wouldn't get too caught up on that. You know, I don't know which of the many techniques I'm going to use. Pick one, it'll probably work.
Okay.
If I tell you what to do, then don't pick the other one. Right? So if I say you have to use the divergence theorem, you have to. Or Stokes or Green's or whatever. Next question.
Going back to that first question, can't we just pull out the square root? Everything that's in the square root, pull it out and then just.
Oh, do you mean that horrible one that Eleonora was talking about?
Yeah.
The limits on Z has X's in them, so you couldn't.
Oh, okay.
I'll try and find it, but I'm pretty sure the limits had.
Bad for a while, but then you get it down to where you have to integrate in terms of X, and then it's kind of bad.
Yeah. Oh, you're assuming that, right, this has X's and Y's in it, right? So he was saying, oh, can I pull this out and stick it over here? Well, I guess you could, but it's not going to help you any because it's just going to defer the pain until later. So you might as well just do it. And whenever I see limits that have X's and Y's in them, I tend to keep everything together until that's disappeared. And then you've got X's and Y's with numbers. And hopefully whatever's left over is doable. But in this question here, the things that were left over were not doable. I mean, look at, I guess I could follow that out, but it's going to be.
I mean, in that right there, that last integral, you could just pull that 7 minus x squared quantity squared, pull that to the dx, and then
here, but you can't
integrate
because
r.
that's the X
Well,
is
it's
here
just a
as well.
constant, isn't it? It's just a constant.
They both.
Oh, I guess, yeah. I guess.
Integrating with respect to y isn't hard, but then integrating with respect to
X,
x.
yeah.
The X is going to kill you,
Yeah.
right? The X is going to kill you. Now, if you pull that out, which I guess you could do if you wanted to, you're only prolonging the agony. You're still going to have to be left with these guys.
Yeah.
So if you were thinking, maybe if I did it in a slightly different order, or if I pulled things out, I might be able to get an integral that I can do. Unfortunately, you're never going to avoid the fact that somewhere along the line, you're going to have to integrate this with X. And that's what my problem is. This is not a standard integral. This isn't one that a U sub or an integration by parts or anything would really do. I have no idea what the heck that would be done by. It probably would have been done with an X sub. You remember Calc 2 X subs, trig substitution? It would probably have to be done with a weird X equals √7 sine of theta. Oh God, that would take forever in the day.
I think you're right, though. Trig substitution's probably the way to go with that.
Yeah, but I mean, that in itself would add another 15 minutes onto this question. I mean, this question's just growing into a monster as we speak. And you'd have to do it twice because you'd have to do it to this one as well because these two do not end up being the same thing. I mean, you still do the same X sub, but I would probably still separate it.
I think, like, by the time you have it down to where you're integrating by x's, because when you're integrating by y, with most, if you distribute that root in with most of those, you're just adding a y on because all the x's are constants.
Yeah, so you're kind of doubling this. It's a bit like sticking a 2 in the front of all of this. Good, interesting question. And yes, your answer is you could have pulled it out, but it wouldn't have helped in the end. It would have just postponed the agony to a little bit later in the process. Okay, we got another question.
Could you do number 16 from 16.5?
Is that one you can read out to me? Or will I go looking for it?
I think I can find it.
Okay.
So the vector field is 3e to the xy sine z, and then 4y inverse tan of x over z.
Ugh.
And then, oh, there wasn't any I, so that's J and K.
So 0, that one, that one. Okay. What you've been asked to do here? Is it another div and curl thing?
Yes.
Okay. Do the curl. In the operators. 0. And we're going to get so many i's, take away so many j's, plus so many k's. Okay, let's do this one first. If you differentiate this with respect to y, you get 4 inverse tan x over z's. Take away this thing with respect to z, so take away 3e to the xy cosine z. If we do the middle one, you're going to do this guy with respect to x, take away nothing. And this guy is going to be messy. Differentiating with respect to x, you are going to get 4y. The derivative of an inverse tan is 1 over 1 plus the thing squared times the derivative of x over z, which is times 1 over z. Oh, God in Himmel. Let's see what that looks like. I'm going to have a 4y on the top. I'm going to have a z, a 1 plus x squared, z squared on the bottom. If I distribute the bottom with the z, I get a z plus x over z. If I multiply the top and bottom by a version of 1 called z over z, I get 4zy over z squared plus x squared.
Right.
Does that look good? You know how careless I am. This guy's a constant. 1 over this thing squared times the derivative with respect to x. X on the top, z just gets you 1 over z. And then these lines are just to make it pretty. So if I don't get any, you made a mistake here, I'll assume that's right. Okay, if we go this way, with respect to x, you get, well, take away nothing, so let's put in the take away nothing first. With respect to x, you're going to get 3e to the xy sine z times the derivative of xy with respect to x, which gets you another y. So you've basically got 4 inverse tan x over z's, take away 3e to the xy cosine z, negative this guy, and this guy. God, that's ugly. Does that look good for those who've been watching me? If there's anything obvious, this is probably a time to tell me. If I do the div, this guy with respect to X, this guy with respect to Y, and the worst one is this guy with respect to Z. Well, if you thought that was bad, let's look at what the derivative of this would be with respect to Z. It starts off the same, 4y, 1 plus the thing squared, times the derivative of x over z with respect to z is negative x over z squared. Think of 1 over z gets you minus 1 over z squared. So x over z gets you this. So what I'm now going to do is multiply everybody in the top together. And z squared times this guy gets you z squared. And z squared times this guy gets you x squared. And you get negative 4xy over z squared plus x squared. Okay, that's just ugly. Was it the inverse tan bits that were causing you the trouble, Anna?
Yeah, also I think it was just a lot to keep track of.
Yes, which is a miracle that I didn't make a mistake, but it might mean I've made a mistake and nobody's bothered to find it. But there are lots of places where things disappear that shouldn't have, or signs went weird. And I understand that can happen. But remember, when you're doing your final, you get partial credit. So if something is messy like this and a 2 disappears, it's not like the end of the, it's not like you get 0 out of 25, which is what WebAssign would have done. You get most of the points for doing most of it right. Okay, to finish a few moments then, those who are doing the test on Monday, you will turn up 8 to 10, usual. If you like your test scores and you know it's not going to make any difference because I only count the top 4, feel free to take that time and get ready for your final instead. Nothing wrong with that. I don't need to see you in Zoom if you're doing that. It's probably a distraction to both of us. So only the people who are doing the test need to turn up for the Zoom meeting on Monday. On the day of the final, there'll be a big Zoom meeting, as always, right? On Canvas, I've set up a shell, so you'll go there and you'll think, oh, the final's there. If you go inside, it's empty. But that will be populated when the final starts. So you'll be able to see it. I've also got a shell for the Canvas upload. So you'll see it, but it's not usable yet. General advice. Half the things you study for will not appear in the final. The half you don't study for is the half that will appear on the final. So assume everything is going to be in the final. That's the safest bet. If you get stuck on a question, don't just keep battering away at it. It's much better to leave it and do all the questions you know how to do and then just come back to it. Because everything's done in paper, it's dead easy to do questions in any order you like. And in fact, it's very helpful for me if you can keep the questions to the same piece of paper. I mean, sometimes they overlap into 2 and that's fine, but even if that means there's a space, I'd rather that. Just it's easier for me to grade if I've got 1 question on each screen, rather than, especially if you change your mind, it can get really messy. If it takes you more than 5 minutes to do the multiple choice question, you're doing it wrong, because they should take 5 or less minutes to do. So pick C and move on, or whatever your lucky letter of the alphabet is. In the multiple choice, I do not want to see any working. Well, you just write down 1 is A, 2 is B, and that's all I have. And that might be helpful if you could put that in a single piece of paper as well, just to make my life easy.
Professor?
Yes.
Do we have to put the work on the test paper itself, or can we do it on like lined paper?
Just do it in lined paper. Don't even worry, because not everybody's got a printer. You're
Okay.
just going to see a PDF of the questions so that you know what the question is, but you're going to write it down. In fact, I'll probably be putting the PDF without spaces. So there won't even be room if you printed it out. Well, that's a psychological effect. If you see a test and it's got 12 pages, it freaks you out. But if I put it on 3 pages, it doesn't look that bad anymore, right? It's totally psychological. It's the same questions. So yeah, you write them on paper, line paper, square paper. Just like a test, you know, use Adobe Scan. Make sure Adobe Scan is really clear, because I know that some of you, it's a bit faint. So have a good look at it before you send it to me. And if it looks off, people who've done it, is there a lighting thing that you can do? Should the lighting be not there, or should it be behind you? Has anybody found a good Adobe Scan process for getting nice, dark, easy to read things?
I've gotten the best results with like copy paper or something without lines on it, because it doesn't compete with your writing to get recognized. And
okay, there's a suggestion. Do you know, at the beginning of today, I had a real hassle with one of my lights. I mean, it was, what I could see, it was making everything go really bright and annoying. Maybe a light off would help as well. Not maybe while you're working, but you know, when you're doing your copying, it might be a little bit easier if they're just ambient light rather than, you know, a desk lamp shining right on it. That might cause problems.
taking a picture against a dark surface helps too.
Okay, get good contrast. I'm kind of out of ideas. It has been fun. I know I'm going to see you, but this is probably the last chance for me to see it all in one place. You have tolerated my bad jokes, which is amazing.
They were not all bad.
Okay, thank you. But I was saved by the fact that it was virtual, because you may have thrown things at me by now if it hadn't been. And good luck in the future. This will probably be the last math class you'll get with me. Some of you may have some math classes defect to do or so on, but I'm not teaching them anytime soon. And drop in and see me once we get non-virtual, because I keep candy in my office. And I always found that if you bring candy, they shall come. So seriously think about dropping in. I would love to meet you in person. It's been a fun time. Okay, say bye.